Add and subtract rational expressions. A rational expression is a fraction with a numerator and a denominator that are both polynomials. So when you used to add 1 over 52 plus 7/13, you were adding polynomial expressions. And whether you knew it or not, you were following that methodology. In this lesson, we're going to do addition and subtraction with more complicated rational expressions. Here's an example of the work. And sometimes it's necessary to simplify them to make it easier to graph. Adding or subtracting with like denominators. To add or subtract rational expressions with like denominators, simply add or subtract their numerators. Then place the result over the common denominator. So, very important part, what we have here. So we have 2/13 plus 5/13. Since the denominator is the same, we are going to add the numerator and get 7 over 13. That's our final answer. The same thing applies if you have any denominator that's the same. So even if it's 5x squared and 5x squared, we just keep that denominator. It doesn't matter how complicated the denominator is, as long as the denominators are the same, you can freely add and subtract the numerators. Okay, let's try an example. So if you notice here, we have negative 10x plus 1, and you could put that in parentheses because the expression is together because we have to follow order of operations. Okay, all of this, think of it as one term. All right, denominators are the same, so we can go ahead and add the numerators. We get negative 4x minus 12, all divided by x plus 3. Now, the only way I can simplify things is if I can factor something out, and I can factor out a negative 4. So what we have now is x plus 3 divided by x plus 3 is 1, so our final answer is negative 4. What that means is that if you substitute any number into the expression that we started with, you will get a result of negative 4. Only number you can't substitute is negative 3, because if you did that, negative 3 plus 3 gives you 0. Can't divide by 0. Let's try another one. So here we have the subtraction problem. Again, same thing applies just like before. We have parentheses here, and we can't, here's something you can't do. Okay, I cannot cross out these 2's because they're not factors. So make sure you do not, I repeat, not do that. Let me erase that. And I will continue with the parentheses. Okay. So I wrote it as x minus y minus 6x minus 2y. What's very important is that you have to distribute that negative. So we keep change, and now combine like terms. So we get negative 5x plus 3y, all divided by 2n minus 1. Circle that, that's our final answer. We can't factor anything out that's noteworthy, so we move on. Adding or subtracting with unlike denominators. Now, if you have 1 divided by 52 plus 7/13, now we have to think back to least common denominators. So if you recall, one of the quick ways to get a least common denominator is you could just multiply the two numbers, and that gives you a common denominator. However, you might have to work with larger numbers than you want. So it's always better to work with the least common denominator. And if you play cards, you know that 52 is 4 times 13. So all I need to do is multiply the second fraction by 4 over 4. Now, again, I could cancel this out, and I'm back to what I started with, but it's not really going to help us. So what I'm doing doesn't change the number. I'm really just multiplying it by 1. All right, so we get 1 over 52 plus 28 over 52. We have the same denominator, so we can just add the numerators. And 29 over 52 is our final answer. 29 is prime, so we can't simplify this anymore. Okay, let's apply it to rational expressions. So if you look over here, we have a 3x here. We have a 3 in the other one. So what would be nice is if I could get an x over here. Okay, but I can't just do that. I would need to do it in the numerator as well. All right, that would make it legal. So in this case, our least common denominator is 3 times x. So what I just did there, I'm going to do it properly and multiply it out. And now that I have the same denominator, I could add the numerators. And just for good measure, I'm going to write it in standard form. 17x plus 2, all divided by 3x. Sometimes you might see that written as, try to fit it here, 17 over 3 plus 2 over 3x. If you simplify it, but it really depends what you're doing. For what we're doing, this is probably the best way to express it. All right, let's check. I'm going to check by substituting x equals 2. You could pick any number you want. I have a feeling 2 is going to be a little bit easier. So here's what I started out with, and I'm going to substitute 2. Remember, to help you, anywhere you see a x, take out the x, you substitute the number in its place. Well, we end up with, this was just 2 over 6, because that simplifies. So we have 1/3 plus 17/3 is 18/3, which is 6. All right, that doesn't tell us anything until we substitute it into the answer as well. So, same thing as before, parentheses here, substitute the 2, and just simplify. Use order of operations. And look at that, I get 6 again. All right, that's a good sign. All right, what that tells me is that because the original expression and the simplified answer evaluated to the same amount, our answer is most likely correct. Now I stress most likely because it's not a guarantee. To really guarantee it, you have to check every number, which is, I think, a little impossible. So most likely is very good for what we're doing. Okay, here's another one. Now, here, both of the denominators are both quite different. All right, well, based on that rule before, I could just multiply the denominators, and that's going to give me a common denominator. In this case, it's actually the least common denominator as well. So both denominators need to have an h plus 7 times an h minus 1. What I like to do is I like to rewrite it with a little bit of room. It helps you keep track of your work, and it's much more organized. So the first fraction is missing an h minus 1, so we add it in the numerator. We write it in the numerator and the denominator. The other fraction is missing an h plus 3. Now they both have the same denominator. So we move along. To simplify the numerator here, we're going to have to distribute. Same thing over here. There it is. Since the denominators are the same, I could just write the numerators together. Now, very important that I have, if you notice, I have this minus here and this minus here. And because of that reason, I kept parentheses around both terms. All right, most common mistake I see is people forget to distribute that negative. So just like before, we distribute the negative and we get 7h minus 7 minus 2h minus 14. Combine like terms, we get 5h minus 21, all divided by h plus 7 times h minus 1. You could distribute there. It's not really necessary. I usually keep it as factors just in case I know what to look for later on when there are asymptotes and if something could be factored out. So we can just end it right there. Okay, here's one where we have to add. So if you look at the denominators, I have a linear binomial here, and I have quadratic trinomial here. Now, what would help is maybe if I factor that trinomial. So let's quickly do that. These are things you could do on the side. It's really up to you. Just give yourself enough space to show the work. So now two numbers that multiply to give me 3 and add up to -4 are -1 and -3. And because I have an x minus 1 already here, and there's one here, both denominators just need an x minus 1 times x minus 3. Since the second fraction has that already, I just need to give myself more room in the first fraction, doing that right here by extending it longer, and multiplying the numerator and denominator by x minus 3, x minus 3. So nothing needs to be simplified in the second fraction, but that first fraction needs to be distributed. Now we're not going to use any of these words, or for the fencing fans, these words. Okay, we're going to distribute. So let's do that. We have x times x is x squared minus 3x plus 2x minus 6. And all that gives us x squared minus 1x minus 6. And we're going to add that to 4x plus 2. Because the denominators are the same, I went ahead and just combined the numerators. And you should always look here to see if maybe the numerator can be factored some more. All right, if I look at this, I need two numbers to multiply to -4, but add up to 3. Well, if necessary, you do, a little bit of factoring here. Draw two parentheses, x and x. It's going to be positive and negative. And I'm going to have the 4 needs to be a little stronger. And this is going to be 1. Okay, so erase that because I have a neater one right here. And now I can cancel out this x minus 1 and this x minus 1 because they equal 1. And there's the final answer. One way to check if this is correct, I use Desmos, and I graph the original and I graph my answer, and you get a graph like this. Now there's one discontinuity because of this term down here. So there's going to be a hole at 1, but otherwise the graphs are going to line up perfectly, so you simplified it correctly.